Okay, now here I am explaining using my note. So this is my question. I will upload this note for you to refer, and these are the steps you have to follow up. First of all, I have to define my inputs. Inputs are temperature and pressure. It has given in the question. And the second thing is step 2 is assign the link. So first of all, the output. Output is throttle setting of a steam turbine. And step 2 is assign a linguistic descriptors for each fuzzy subsets. Okay, for inputs, temperature we can assign cool, normal, warm, some of linguistic value as you wish. It's depend on you. And the pressure I am assigning low, medium and strong. Then after for the output throttle setting of a steam turbine. N2 I can say large negative, small negative, 0, small positive, large positive. Maybe this can be minus 90 radiant. So and this is minus this one maybe minus 45, this is maybe plus 45, this is maybe plus 90, and this is maybe 0. But we can't write down these numbers as a linguistic value. We should assign some of values like in readable way, so we are speaking way. Okay, then after I told you we should find out membership functions. For that I am making graph. This is a trigonometric graph. So and you remember this how we made, and I'm not going in detail about this. So and once we made this, we are using some maybe 2 points equation and trying to find out the answer. 2 point using 2-point equation. So 2-point equation is so you know it's the way to find the equation of a straight line. So when we know 2 points on it, we usually write it as, normally we can write it as y1 minus y minus y1 equal to y2 minus y1 x2 minus x1 into x minus x1. So when it simplifies, we can write it as y2 minus y1 divided by y2 minus y1 x2 minus x1 equal to y minus y1 divided by x minus x1. In here y is mu, but in our case mu temperature, and x is x temperature. So these two values we don't know, but we know y2 y1 x2 x1 y1 and x1. So yes, y1 y2 x1 and x2 for each of these graph. In here when we are considering cool, what is y1? y1 is 1, y2 is 0, and x1 is 1, x1 is 0 and x2 is 20. When we are considering about nominal, so we have two graphs in here because these are two different temperature, the temperatures between 0 to 20 here, and this is 20 to 40. So for first range we are taking okay, when we are calculating y1 is 0, y2 is 1, and x1 is 0, x2 is 20. So for the second graph, for the second range 20 to 40 Celsius degrees nominal graph, so the y1 is 1, y2 is 0, x2 is 20, x1 is 20, x2 is 40. In warm, it is same like that, so you can write down. Okay, using those we can apply So in here I have I wrote all of these values, and here you can see how I apply that for this equation and took out these membership functions. We have to write down our ranges also over there. Now we have for mu cool this function, mu nominal this function, and mu warm this function. As well as the same way we are finding out for pressure as well as the same graph, and we can take out until 100, and we have these functions. For the output, for the throttle setting of the steam turbine, so I told you this minus 45, minus 90, 45, 90 and 0. This is N2E. So actually this is starting from here. We are not interested about this. We are just checking out this part of that. In here also, maybe pressure is lower than 0. But we are not checking out it. We are just mentioning this part of the graph. And for the throttle setting, this is N2, this is N1, Z, P1 and P2 in here. And we have 1, 2, 3, 4, 5, 6, 7, 8 membership functions. So then we should take out all of these membership functions and one by one. Then after this step 4, form a fuzzy rule base. Now here we are going to map the input variables along with output variables. So the input variables, now we are making a rule base. We have 3 inputs, and from here also 3 inputs, and low, medium and strong for the pressure, and for the temperature I have cool, nominal and warm. Okay, these are the values for the output for the throttle setting. This is very random. You can put anything in here, but think generally and put low pressure and cool temperature. Maybe P2 we can adjust. In this case also you have to take out ideas from a specialist from a field, but for now we are randomly putting these values. And okay, next thing is we should make out our rules. You can make rules as much as you want, maybe 10, 20, it's depend on you. I'm making out 4 rules in here. So rule 1 is cool temperature. Don't think about this for now, this value, to cool temperature and low pressure. Rule 2, cool temperature and medium pressure. Just in that way I made my rules. You can make many rules, maybe normal temperature and medium pressure, something like that. In here you can say and or, maybe you can use or and. So in my case I use only and. So if you use or, mean if one condition only satisfied, that the outcome will be there. And step 5, the falsification and evaluating the rules. For this, now we have these positions, pressure, temperature according to the rules. I made only 4 rules. For that we can go, first rule is cool temperature and low pressure. Okay, cool temperature and low pressure. If it mean okay, these are the position. Okay, for before that we should think about some of the values, because now for this step it is finished. We made the rule base and everything. Now we can put some inputs and see what will be the output. Okay, in my case I may think my temperature is maybe 12. My temperature is 12 Celsius degrees, and I can say my pressure is 40 Pascal. In this case, where I should make my throttle setting. This is my question. Depend on my fuzzy control system which I made for now. I am now going to find out it. Okay. Based on my rules, now I will go to my first graph. Cool temperature and low pressure. Okay. So what is my input value? Now 12 Celsius degrees. It can be here around. So I will straight my line till these two because it can cut both of these. And I wanted to find out these two values. That's mean these membership values actually. Okay. For that, when we are using Python and doing this, any programming languages, we can find it automatically using our fuzzy sets. In Python, we are using some libraries. Using those, we can automatically calculate this value. But in our case, we have, since we are making it manually, now we have fuzzy membership functions. So we will apply to these fuzzy membership functions and we will find out our values. Okay. Now, cool temperature and low pressure, first one. And we can say this 12 Celsius degrees is cut in cool temperature and normal temperature both. And our first one is cool temperature. We will go to there later. For this matter, for cool temperature, we have to take out our membership function. Mu cool is 20 minus ST divided by 20. The range is 0 to 20. I am applying my value 12 Celsius degrees divided by 20. So then the value will be 8 upon 20. So then 2 by 5. Then we know the value in here is, this is cool one, 2 by 5. So this is the value I put in here. So then for low pressure as well as cool temperature, so for all of these you have to find out this value. Apply this value. For the pressure also you have to apply. So go to there, your pressure, and you know this is 40 Pascal. That will be like in here. So now you have to find out this one and this one, where it is cutting these lines. Okay. And for that you can apply into your membership functions and you can find out these values. Okay. I already found these values. You have to find these values for you. For your rule set. Maybe you can change this rule set and make it. And now I know from this, for this rule set, I found out my outputs from my rule base. For cool temperature and low pressure, cool and low pressure, so P2 will be my position. So then, like in that way, I wrote down all of these position for my input values. Okay. Then after, now I am going to do my defuzzification. For that,